If we had a large quantum computer, what would we do with it? In principle, a universal quantum computer can perform any logic operation. But the real advantage of using quantum computers comes only if we can find an algorithm that uses the exponentially large amount of information that can be stored in the quantum states to arrive at the solution in a smaller number of steps. We have seen the example of the quantum search algorithm, which can find an item in an unsorted database using a number of steps that is only the square root of the number of items. Another famous application is the prime factoring of large numbers, which has implications in cryptography. But perhaps the most exciting application is to use quantum computers to simulate other quantum systems. Precisely because of the exponentially large complexity of quantum states, simulating quantum systems on a classical computer is exponentially hard. This is why we cannot easily simulate and design molecules or drugs or advanced materials on a normal computer. Those are quantum systems whose complexity doubles every time we add even a single particle. There are two main challenges ahead of us. First, the hardware is very sophisticated and very delicate. We will need many years of work from large, well-funded research teams before we can reliably build quantum computers with enough qubits to be really useful. The good news is that we might be able to do so using a similar technology as what is already being used to build the incredibly small silicon transistors we have in ordinary computers. The other challenge is that of finding useful quantum algorithms. At this moment, we only have a handful of problems for which we know there is a quantum algorithm that runs faster than a classical one. Part of the reason is that we don't have yet a quantum hardware powerful enough for quantum software engineers to test and debug their code. So we hope that the progress in quantum hardware will go hand in hand with that in quantum software. We are now at the cusp of a quantum revolution that can provide us with computational machines with a power never seen before. It's a very exciting time to work in quantum science and engineering, and a very exciting time to invest in what could be the most transformational technology of the 21st century.